Hello, my name is Jamie Osborne. Let me introduce you to Watson, my assistant. Hey, wake up. He's not a very good assistant. Hey, it's not that bad. In this video, Watson and I are briefly going to discuss nominal, effective, and real interest rates. Hey, you should probably be careful with that. Too late. Okay, that went better than I expected. First is the nominal interest rate. This is typically the rate that is quoted by the banks or credit cards and normally given in percent per year. Next is the effective interest rate. This is the true interest acquired due to the effects of compounding, where compounding is the addition of the earned interest added to the balance. This addition of interest can happen daily, monthly, or continuously, or any combination. Finally is the real interest rate. This is the effective interest rate minus the effects of inflation, which gives a true change in value. Watson, whatever that is you're doing, stop it. Next, let's talk about the equations associated with each interest type. First, nominal interest, where the future value equals present value times 1 plus nominal interest rate raised to the n, or sometimes t. This is the time. In this case would be years. Next is the effective interest rate, where future value equals present value times 1 plus nominal interest rate over the number of compounding periods raised to the number of compounding periods. If this was compounded annually, n would equal 1. If this was compounded daily, n would equal 365. Or if this was compounded monthly, n would equal 12. Finally, we have the real interest rate, where real interest rate equals 1 plus effective interest rate divided by 1 plus the inflation rate, all minus 1. Oh, Watson, did we forget something? That's right, effective interest rate has a different equation if it's compounded continuously, which is future value equals present value times the exponential raised to the rate times the time. And for this equation, the rate is the nominal interest rate. Let's do a little example for everybody. Imagine you have a savings account that earns 6% nominal interest compounded monthly. What would the effective interest rate be, and what would the real interest rate be? We can rearrange the equation above to get the effective interest rate, where effective interest rate equals 1 plus 6% divided by 12 months raised to 12 months minus 1 equals 6.168%. Next, we have the real interest rate, which equals 1 plus the effective interest rate divided by 1 plus the inflation rate. Assume an inflation rate of 2.5%. This equals 1 plus the effective interest rate, which was 6.168%, divided by 1 plus 2.5% minus 1. We almost forgot to include the minus 1. This gives a real interest rate of 3.578%, which is less than the effective interest rate. Say goodbye, Watson. I hope this helps everybody with interest rates.